In chapter 5, we'll talk about uniform circular motion, where the object is moving in a circle. So to define uniform circular motion, it's a motion of an object traveling at a constant or uniform speed on a circular path. You can look into figure 5.1, page 121. The circumference of the circle is 2 pi r. R is the radius, and t is the time to complete one cycle. In this example, which is in figure 1, the motion of a model airplane flying at a constant speed on a horizontal circular path is an example of uniform circular motion. So if we know the radius and we know the time to complete one cycle, we can always find the velocity, because velocity is circumference length divided by the time. Now look at this picture, which is figure number 2 in that page, which is here. Let me tell you, the page number is that's the beginning page of section 2. Okay, look at this. We have an object which is moving at an on a circle, and remember, the velocity is always directed towards the center of this circle, and this is what you see here, and it's an example of uniform circular motion with the velocity at different positions. And in part B, the velocity vector towards the point P, which is, depending on the situation, the circumference, a point on the circumference, and also the center of the circle, which is the radius. Well, look at, we're taking two segments from the previous picture, which is 5.2, and we have similar triangles here, and the section of the velocity time t and t0 is differed by an angle theta, as you see here. Now the object moves along a circle from O to P, and the radius r traces a similar or the same angle theta here. This sector COP has been rotating clockwise by 90 degrees relative to the orientation, as you see in figure 2. So we can compare these to a similar triangle type of situation. So now we can, depending on the figure 3, delta V over V equals B delta T over R from the other segment. So delta V, as you see, we divide that by delta T, and we have B times B over R, because this is your delta V over delta T, which is equal to this. So we can compare these two, and finally we'll get delta V over delta T equals to acceleration, change in velocity with respect to time, and which is equal to, when we substitute here the right hand side, we end up with B times V over R, which is finally acceleration, which is V square over R, and this acceleration is called centripetal acceleration. We'll be defining now how to find out the centripetal force. As you know, force is mass times acceleration. So you have Fc, we define that as centripetal force, which is mass times V square over R, and centripetal force now always moves towards the center of the circle. Go over the example 7, page 126. We are going to the last section, which is banked curve, chapter 5, section 4, page 128. Refer to figure 510 in page 128. We'll consider a normal force to how it acts in figure 510b. So Fc, which is centripetal force, equals Fn sine theta, which is mv square over r. Now you have this Fn sine theta divided by, if we divide Fn cosine theta, you will end up with mv square over r over mg. mg is acting downwards to the weight, which is your Fn cosine theta. Finally, you have tangent theta equals v square over r. So now look at this. If the tangent theta is increasing at an angle which is really good, very good, so it will not be a good one, or it's not a good design in the road to travel either vehicle we are talking about. Okay, look at this last picture you have. We are resolving the force, which is centripetal force depending on the circle here. We resolve that to F cosine theta, F sine theta, so that F cosine theta is your weight. That's what we put in the equation to get that final tangent theta. This ends your chapter 5. So we covered only chapter 5, section 1 through section 4. So please make sure that you read the examples as I mentioned to you in my lecture. And for all of your information, I'll take a little bit of time and I'll try to finish it by Friday or Saturday this week. Your homework and exams, all that. And hopefully it might be before that, but Friday will be the last day I would finish everything. So you can look into your homework assignment grades as well as your exam grades. And again, one more thing to mention you, the next exam, which will be exam 2, will be multiple choice questions, so it might be easier for you guys to spend less time as you did this time. Okay, thank you very much. Have a good night. I'll talk to you later.